Hello friends, so I'm back with another important topic in theory of computation, that is simplification of CFG, means context free grammar. This is the major important step before you convert the CFG into the normal forms. So let's see in detail with examples. So what's the simplification of CFG and why it is necessary first. Later on we'll go with examples. See, first of all, the definition. The process of deleting and eliminating of useless symbols, unit productions and null productions is simplification or minimization of the context free grammar. See, there are three terms: eliminating useless symbols, unit productions and null productions. Three terms. You have to make sure that all these three were deleted or else removed from the productions. Then you can say that it is the grammar is simplified or else minimized. Okay, why we have to do this thing? Why we have to simplify the context free grammar? The answer is we have to simplify the context free grammar to make it more efficient and compiler friendly. Like you will be doing this doing a process known as parsing. We will get to know about this in the later. Parsing in the sense it's of two types: up down parsing, down up parsing, two types. During this parsing, if it is simplified, it is easy to parse the grammar. So to make it more efficient and make it compiler friendly, you need to minimize the grammar. Okay, so that's the reason. Simplification involves three steps: removal of epsilon transitions, removal of unit productions, removal of useless symbols. Let's see what are these one by one in detail. The first one, removal of epsilon transitions or null productions. Generally, the productions which are of the form of, in the right side of the production, if there is epsilon, then that is known as epsilon production or else null production. Okay, any production of the form A tends to epsilon. A is some non-terminal symbol which is tends to, which produces epsilon. So that type of production is known as epsilon production or else null production. Okay, we have to remove this by replacing equivalent derivation. Okay, let's see the example. See, here productions are given as S tends to capital A, B, capital B. A tends to A, comma, A epsilon, B tends to B epsilon. See, if you write productions, let us write these productions. The first production is S tends to A, B, capital B, and second production is A tends to A epsilon. A tends to A tends to epsilon. B tends to B, B tends to epsilon. So, number of epsilon transitions in these productions are 2. A tends to epsilon, B tends to epsilon. Now we have to eliminate these two. To eliminate these epsilon transitions, where and all B present, substitute there as epsilon, and where and all A is present, substitute there epsilon. First of all, in S. So, write the first production as it is: A, B, B, and in place of capital A, substitute epsilon. Okay, you will get B capital B. In place of capital B, substitute epsilon. You will get capital A small b. In place of A and B, substitute epsilon and epsilon. You will get only B. Okay, the rest of the thing remains same. A tends to A and B tends to B. Hence, epsilon transitions are eliminated. Understood? Where and all epsilon, any production which gives epsilon production, then replace the production symbols with the epsilon in each and every production, and later on you can eliminate both of these. Okay, that's the thing. So this is the simplification. So let's see another example. Okay, S tends to A. Okay, these are the productions given, and find the epsilon transition here. A tends to epsilon. This is the only epsilon transition in the given productions. So you have to replace A with epsilon in each and every production. So the first production will be, just a minute. So the first production will be S tends to A. Write all the production as it is first. B, C. Now replace A with the epsilon, capital A with epsilon. You will get A epsilon, right? So you will get A only. A, since A is already producing here, you may write or you can neglect it. Okay, next. capital A. Capital A tends to AB and epsilon is removed, right? Okay, no need to write epsilon now. Capital B tends to capital A. A is first write it as it is and replace A with epsilon. You will get small a. Capital C tends to A, C, D. There is no A term here, so you no need to substitute anything. And capital D tends to there is no capital A term, so you don't need to substitute anything here. So simply, so this epsilon transition is eliminated in the production. Simple. The non-terminal which is producing epsilon, substitute that non-terminal as epsilon in each and every production. That's it. Epsilon terminal will be eliminated. Epsilon production will be eliminated. So next, second step is removal of unit productions. We have seen epsilon productions. Now we will see unit productions. Unit productions in the sense non-terminal which tends to non-terminal, single non-terminal. Okay. In the right hand side you should have only one non-terminal. If it is of the form, then this production is said to be a unit production. So let me share this. Let me see this. Suppose A tends to B. Okay, and B tends to small a. Okay, it's taking two steps, right? If we replace like A tends to small a, there is no change to the grammar. So A will be tends to small a only. Okay, there is no change for the grammar. So instead of using this extra terminal B, we can write directly like this, right? So that's what we are going to do in the case of unit productions. See the example. S tends to A, B. Let me explain it. Okay. Find out the unit productions first. C tends to D. This is one unit production. B tends to C, unit production. A tends to capital B. This is unit production. Remember, single non-terminal, not terminal. Single non-terminal should be. Okay. So the epsilon, the unit productions are C tends to D, B tends to C, A tends to B. Always if there are unit productions in continuous, solve from downward direction. Okay. D tends to D, there is no change in this, and C tends to D and C, right? Small c, this is. So instead of this capital D, replace the transitions of capital D. The transitions of capital D are D. The transitions of C already existing are C. Okay, right, guys, please. Next, B. B has unit production C. So replace this capital C with the productions of C. Okay, productions of the C are D and C. So D or C, already B is producing B. Okay, write it as it is. No change. Now next, A. B, right? Unit production B. Replace this non-terminal B with productions of B. D, C, B. Okay, and A is producing by B as it is. Write it as it is. Now S. S tends to A, capital A, B. Finish. Simple thing. So where and all you will get unit transitions, instead of this non-terminal, substitute the production part of that non-terminal. That's it. So this is unit productions. Now next, the most important and the last step is removal of useless symbols. Okay, useless symbols are something which are not involved in the derivation of the string. Like context-free grammar is a grammar, right? So finally it should terminate. Like you will be starting from the start symbol yes, right? So at the end you should be end up with all the terminals. You should not get any non-terminals here. You should end up with all the terminals. Okay. For those people who are confusing with terminals and non-terminals, sir have given a most very useful clue to remember this. See, non-terminal is a big word, right? Big. It's a large word compared to terminal, right? So big in the sense capital. So uppercase letters. Terminals. Terminal is a small word, right? Compared to non-terminal. So terminals are small case letters. Remember this, you won't even forget in your life. Remember this example. Non-terminal, bigger word, so uppercase letters are non-terminals. Terminal, smaller words, so small case letters are terminals. Okay. So now let's see the useless symbols. So if you start from production, yes, you have to end up with some terminals. I mean, the string should terminate at last. So then only it's known as valid grammar. If not, the string cannot be derived from that grammar, right? So the variables which are not involved in the derivation of any string is useless symbol. So using that variable, we are not deriving any string. So those symbols are known as useless symbols. Useless symbols are of two types. One is non-generating and second one is unreachable. Let's see about each and everything. Non-generating. Non-generating in the sense, symbols can be reached from the start but does not derive any terminal. See the example, S tends to and S tends to A capital B. So see, the productions are S tends to S tends to A, B, and the second production is A tends to B. So see now this capital B is there, right? So you are reaching to capital B from S. After that you can't proceed further, right? Since there is no production using a B. So this is useless symbol. B is useless symbol here. So you have to delete entire production. So it will be S tends to A capital A tends to B. So this is the only production will be remaining. Okay. The useless symbols are nothing they are not specified. From S you can reach B, but from B you can't proceed further, right? So why that is known as non-generating or useless symbol. Okay. Removal of non-generating symbols include removing along with the productions, like if there is another production like a BA, let's suppose, then you have to remove this entire production. You should not tally this. You have to remove this entire production. Okay. Next, second thing is unreachable states, variables that cannot be reached from the start state. See, remove them along with their production. Same, the removal method is same. See the productions example. S gives rise to A capital A and as B. A gives rise to small a, B tends to small b, capital C tends to D. See, this thing, C is telling that if you use me, you can reach to the small d. Okay, but see the start state. You can reach only to the capital A and capital B using start. You can't reach to the C. And further more productions also you can see there is no C involved in the right side of the productions. So if there is no variable involved in the right side of the productions, then that variable is known as unreachable state or useless state. Now you have no work with this C variable, right? See, you have no work with the C variable. It is not occurring in any one of the right side of these productions. So you can easily neglect this. So the productions will be S tends to A, B, and A tends to A, B tends to B. Okay, let's see an example solving including all this, so you will get more clarity. And remember one thing, you can follow any order, but the order I recommend is first remove epsilon productions, later on remove unit productions, later on go for useless symbols. Okay, fine. First remove epsilon productions, later on remove unit productions, and later on go for removing useless productions. Otherwise there will be confusions will be arise. So let's see one example. Okay, these are the productions given. S tends to capital A, S A capital B, small b. A tends to B, and B tends to small b and epsilon. The first and foremost step is removing epsilon transition. Find out epsilon where it occurs. B tends to epsilon. This is epsilon transition, right? So to remove this B tends to epsilon, substitute epsilon where and all B occurs. So B occurs here, right? So substitute epsilon here and here. So S tends to write the productions as it is, existing productions as it is, A, S, A, and A, B, and B as it is. Next, in place of capital B, substitute epsilon. You will end up with A, right? And A here. Next, A tends to capital B. This is existing production. Next, substitute epsilon in the place of capital B. You will end up with epsilon. So you should write epsilon. Next, B. B tends to B. We are removing epsilon transition, right? So B tends to only B. Okay. The next epsilon transition was this one. A tends to epsilon is the epsilon next epsilon transition. Now, in place of A, substitute epsilon. Okay. Now, first write the existing productions as it is. S tends to A, S, A, and A, B, and B, and A. Write these existing productions as it is. Now, in place of A, substitute epsilon. You will end up with S, A. Now, instead of this A, substitute epsilon. You will end up with A, S. Okay, A, S. Substitute epsilon in both the positions of A. You will end up with S. Okay, yes. Next. A tends to B. Since we are eliminating epsilon transition, A tends to B. B tends to small b. Okay, that's it. We have removed epsilon transition. Is there any epsilon? Check. No. So we have removed epsilon transitions. Now the second step was to remove unit transitions. Okay, unit transitions are this one. See, non-terminal is tends to single non-terminal. Okay, B. So this is unit productions. What I have said for the unit productions. What I have said for unit productions, simple. Instead of this non-terminal, substitute the terminal. I mean production, the whole production. So instead of this B, substitute the production produced by the capital B. I mean non-terminal B. So it's producing B. So instead of B, replace small b. That's it. Instead of B, replace small b, and B tends to B. Okay. We have removed unit transitions also. And the third step is to check for useless symbols. There are any useless symbols? See, A has been used here. That's not useless. And A tends to terminal, so it's used for terminating, not useless. And B also has been used here, so it's all not useless symbols. And any more useless symbols? No. So there are no useless symbols in this example. So this is how you have to minimize the grammar. And let's see more examples in the further sections. And this is a simple explanation to make you understand what's the minimization and why it is necessary in an easy way. And if you have any queries, comment down, and I'm glad to receive all your feedbacks in the comment section. Thank you. I'll back with another topic like normalization of context-free grammar. Thank you guys.